Hi everyone, I'm just going to, in this video, introduce you to the idea of Pythagoras Theorem or Pythagoras rule. I'm going to use a program called Geogebra or Geogebra, depends how you want to pronounce it. When you go to this website, I've actually got an account, I've logged in, but anyway, on the main page you should find a button that says Start Graphing, so let's press that. And what we'll do, I've got the sort of calculator down the bottom here. I'll close that and I'll just move this over a bit on the left here, resize. Now on the board we've got a grid, and what I want to do is, if you right click, I'll turn off the axes, and also I think I'll zoom in. So there's my grid. Come over to the left, and there's a button, a circle and a triangle, overlapping triangle, that's your tools. If you click on that, then I want to construct a triangle. Just come down and press more, and then there's a polygon tool to create a polygon. Here it is here. So press that tool and just press on the screen. Place 3 points. You'll see it'll construct a triangle. After you've placed 3 points, just press back on point A, and there's your triangle. Now what you have, if you go back up on the left here and click on the move tool, which is the arrow head, you can just click on and drag a point. Okay, next step, we're interested in right angle triangles because Pythagoras is doing right angle triangles. So there's a right angle triangle. Just to confirm that we have a right angle, you can actually get this program to measure the angle for you. Under measure there's a command called angle. So to measure the angle, if you have the triangle like I have, if you press that, press on the C, so that's one leg of the angle, press on the point where the two legs meet or the two sides meet, press on B, and then press on A. And you'll see when it's a right angle triangle, you see it puts in alpha is equal to 90 degrees. Press on the move tool and you can move the point away, and you see we get a bigger angle. So here's an obtuse triangle, that angle there is 143 degrees. Okay, we're almost ready now to do Pythagoras theorem. I'll just pause the video for a second. So what is Pythagoras theorem? It's to do with the lengths of the triangle. So what I want to do is I can use this tool under measure, press A and B, and I'll put the length there as AB, and I'll do the same for the other side. So I'll press on B and C, and BC is 3 units, you can see from the grid. And then this, if you press I'll go CA, we get the length for the longest side. Now one thing you should notice of a right angle triangle, I'll just move these lengths out, is in a right angle triangle, the side that's opposite the right angle, so here AC, is always the longest side. So let's check that. I'll drag this point out, make this a bit longer. You can see there that CA is about 8 and BC is 4, AB is 7, and that makes sense that you know, when you form a right angle, the line that joins A to C must be longer than the other two sides. If the side ever gets closer and closer, you can see here as it gets closer and closer, CA, as we make a smaller and smaller right angle triangle, you'll see CA is getting closer and closer to the 7. So eventually CA can only ever equal 7. When you bring that point right down, you see you no longer got a triangle. So that's pretty ridiculous. And you can make these sort of even, but of course then you see there both sides are even, the right angle triangle, you've still got a hypotenuse, we call that the hypotenuse, this length here, is still longer. Okay, let's look at the idea of Pythagoras, which is the main focus. I'm going to use my calculator, and what I want you to see is, let's have a look at the calculator. What I'm going to do is I'm going to square the two shorter sides, so the AB and the BC. So let's type that in. You get 7 squared, so use the square key, plus 3 squared. You get 58, okay? Remember that number. Now what I'm going to do is I'm going to square the hypotenuse length, so the longest side. All right, keep that in mind, the longest side. So 7.6158, and square that. Now allowing, there's a little bit of rounding here with this number, 7.6158, and you see we're very close. There's the previous answer using my calculator, 58. In fact, probably what I should do is I know there's what's called a Pythagorean triplet. Put that on 4, and here I just need to put this on 3, and here you get the famous Pythagorean triplet. Actually they call it it's not triplet, but anyway. And let's check this one. 3 squared plus 4 squared equals 25, and of course 5 squared is 25. So you can see here there's a relationship that's always true for right angle triangles, that the square of the shorter sides, BC here and AB, added together will always equal the square of the longer side, or the hypotenuse, which in this case is 5, which is 25. So that's Pythagoras' theorem. One final thing. I'll just take a little break there to get my breath, have a break from talking. Let's look at a triangle that's not a right angle, and here it is here. And you can see here, and this is the key thing, this is why this is special. So if I put in 4.4721, square that, add to it 4 squared. So I've squared those two sides, BC and AB, and you get about 35. It's close to 36. Now we'll do 7.2. In fact, you should already know 7 squared is not going to give you 36. It gives about 49. And you get 51.9, so you get close to 62. So see the difference there? That's not a right angle triangle. So Pythagoras does not work for non-right angle triangles. It must be a right angle triangle, something like that.